Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know. Hello everybody, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know. No issues? That's great. And I'm audible, am I right? Like there's no problem with the audio as well. It's not too less or too loud or something like that. Okay, awesome, awesome, awesome. Welcome to today's class. The first class for data structures and algorithms got cancelled due to the internet issues. So I came back from the office to home, and I'm conducting the class from home itself this time. So I don't think so there should be any problems with the today's class itself, guys. Okay. Okay, great. So let me know, guys, what have we studied in our previous class? Can you guys let me know what have we studied in our previous class, guys? Can you guys let me know what have we studied in our previous class, guys? Lists. Okay, we started to work on lists itself. Right now, our focus will be on NumPy. Okay, NumPy. That is what we are going to start from today onwards. It's very important from the perspective of the project that we'll be working upon. If you are getting into data science at any point of time, whether it be machine learning, deep learning, or something else, NumPy is something that you will be using at every single time, guys. Okay. So the notes for today's class, I'm going to provide it in the live chat itself. Give me a second. Khushi Rajput, you can fill the attendance right now. It's still open. We haven't closed it. Okay. So right over here, I pasted the link for the NumPy notes. I've pinned the link up in the live chat as well. You will be able to get the notes for today's class in the live chat. Okay, I pinned it out as well. This is the notes that we are going to utilize for learning NumPy. It's pretty simple, pretty concise, and everything that we are going to discuss, I've put it up properly right over here, so you won't be you won't be having any kinds of issues. What happened to C++ day 2, sir? Kushal, basically we were having some internet issues and hence we were not able to conduct the class properly. That is the reason why we have just shifted the class tomorrow. So the day 2 will happen tomorrow as well. Can we access the notes after the live? Yes, of course. That's the reason why I'm providing you guys with the notes as well. So you don't have to worry about it. I think so. You are asking about Shape AI. So that was the original name of DevTown. Right now we have renamed ourselves to DevTown itself. I'm so sorry. So graduation year basically means when are you going to leave the college? Okay, so that is how you treat the graduation year. Okay. Is linear algebra important to go deep in machine learning? See, mathematics would be a huge part of machine learning at any point of time. Okay, you have to be good at mathematics. So data science is a particular field that I feel should be only for those people who are really interested in mathematics. The problem with I will be explaining this in a future class as well, but I will just make it concise and tell you right now. There's nothing like machine learning. Okay, there's no role as such where you just work on machine learning models. Okay, there's no particular job like that. There's no job that just works on the deep learning models. There's nothing like that. It is just one of the tools. It's like a screwdriver. I can be a carpenter, I can be a plumber, I can be an electrician, but I need to carry a screwdriver. Now the screwdriver isn't the only tool that I'm going to use. I need a lot of different tools that is going to be there. Okay, but mathematics is something that will be common in all these fields. Machine learning is just a very small part of it. Like hardly as a data analyst, as a data scientist, when I was working in Reliance and Geo, I hardly used machine learning for, I guess, like 10% of the time, or less than that, like 7% of the time while I was working there. All the other time I was just using exploratory data analysis, statistics, SQL commands, Tableau, Power BI, all these different tools I was using. But machine learning is a very, very, very small part of all these stuff. So please do remember that. Okay. Okay. Is complex mathematics or basic mathematics, like 10th and 11th standard or 12th standard mathematics is more than sufficient. Okay, you don't need to know more than that. If you have knowledge up till 12th standard mathematics, that's more than sufficient. Of course, above that as well, for example, statistics isn't being covered in your syllabus up till the 12th standard. So statistics is something that you will have to do it on your own. But yeah, 12th standard, up till 12th standard would be more than sufficient, guys. Okay. Okay, so shall we start with our today's class, guys? Please do let me know. Shall we start with our today's class, guys? Please do let me know, guys. Shall we start with our today's class, guys? Please do let me know. Awesome. So again, we'll be starting off with Google Colab itself. So just open up COLAB collab.research.google.com. I think so. This will open up the wrong file. I will just open it up once again. Array. Okay, so I will go to GitHub. Then I will copy paste the URL that I have provided to you guys in the live chat itself. That is the link to the notes for today's class. I will be pasting it inside of GitHub, and then I will be just clicking on this particular search button, and that will start off with this as well. Okay. Okay. I am able to understand that many of you guys have are using like YouTube for the very first time. So that is the reason why you are not able to see the the screen is not clear or something like that. So if that's the case, guys, do not worry. Okay, I will help you guys out with the same as well. What you can do is it's pretty simple. Do I have a green screen? I have a green. Okay. So what you can do is very simple. You can just focus upon these settings button that is there. You can click on it and you can update the quality of that to, I guess so, like okay, close 1080p or 720p. I think so. That should be more than sufficient, guys. Okay. Okay. Let's get started with the class then. Okay. So Numpy, okay, or numerical Python, that is the full form for Numpy, is a fundamental package for scientific computation in Python. Okay, so all type of your scientific computation that happens, we use this particular package in Python. Now, what do I mean by package? So somebody has already written all the code for you. Okay, you don't have to do any of the work. All the different stuff that you use usually in mathematics and normal scientific computations, okay, that has already been written. Okay, the code has been written, all the algorithms have been in made right over there, so that you don't have to do it. Everything is optimized. You just have to use it for your own purposes, and that is what the NumPy package is. Okay, or numerical Python. Okay, NumPy provides Python with an extensive math library capable of performing numerical computations effectively and efficiently. Okay, now one of the main features of machine learning models is dealing with matrix data. I hope that everybody knows what a matrix data is. Please do let me know, guys. Matrix data that you have studied in your mathematics, I think so, in your 10th standard itself. Do you guys remember that? Please do let me know. Give me a second. I need to take up my medicine. I'm not able to breathe properly. Give me a second, guys. Great. So now that you remember what these matrices were, you matrix multiplication, matrix addition, all these kind of stuff in NCRT mathematics, CBSE, if you have done it, you must be able to understand that. So you don't have to worry about it. Okay. So yes, 2D arrays and all this kind of stuff, you must have learned it. It is super simple and everybody has done. I think so. Everybody here is in college itself. So that is something that everybody knows. So that is what we will be using the Numpy package mostly for to deal with such type of matrices itself. Okay. These were all in 12th standard. Okay, that's great. So yeah, so let's continue from right over there. Now you will be wondering, why do people use NumPy? After all, Python can handle lists. Okay, lists can also, we can like convert it into two-dimensional or something like that. But yeah, Python can do that. Python has lists. Why do we require NumPy? Okay, so that is a particular question that we need to answer. One of the main features of NumPy is its speed. When compared to just normal Python, okay, when you are just using normal Python, okay, it is extremely slow. Whereas your NumPy, okay, speeds up the entire process by using some optimized algorithms to do some basic mathematics. Okay, so all the research and everything that goes around in the entire scientific community, all the algorithms that have been made to how to compute like matrix algorithms or all these to a very high level of precision and at a very fast pace, all that have been put up and implemented inside the NumPy package. Let us look at one of the things. Okay, let us look at how we are able to compute the mean of a particular list. Okay, you are having a list of numbers, you want to find the mean. Okay, you guys understand what a mean is, am I right? You guys understand what the term mean means, am I right, guys? Please do let me know. The mean is basically the sum of all the numbers in that list divided by the total number of elements in that list. As simple as that. Average. Okay, sum of all the elements that is present in the list divided by the total number of elements that are there in the list. So what we are going to do is we are going to calculate the mean using normal Python, and then we are going to calculate the mean using NumPy, okay, of the same list. Okay, we are having a list that we are going to create, and it will be having 1 billion parameters. Okay, that is 1 billion elements will be there in that list that will be ranging from 0 to 1. Okay, so there will be 1 billion elements in the list, then the numbers will be ranging from 0 to 1. Okay, and we will be calculating the mean or the average of that using both Python as well as NumPy, and we'll be checking the time it took to calculate the like to see the difference. Okay, time it took to run that particular line of code. Now, how do you usually like okay, Spotify as well? I didn't know about that. So how do you usually calculate a time? Okay, if I'm giving you a stopwatch, okay, if I'm giving you I'm giving you a watch. Okay, I'm giving you a watch. I'm having a particular person that is going to take up a lap around a particular park. Let us see that in a physical sense. Is it just me, or does he look like Loki Nati? I can guarantee you that I'm like 6 feet and I'm a bit more on the fatter side when compared to Kariminati. I shouldn't be saying fat, I should be saying healthy. Okay, otherwise somebody will be like, I don't know, like people get offended at the little thing. I cannot even make a joke on myself. Arey, shit. Okay, give me a second, guys. So extremely simple. What we want to do is we are having a clock. Okay, let's say that we are having a clock right over here. Okay, I've given you a clock, and we are having a particular like round. Okay, we are having a particular ground itself. This is me. Okay, I will draw myself. So this is me right over here. I'm wearing my specs, bit of hair, above and below. So the above here I'm not able to make it. So this is me. Okay, I'm going to run around the entire field. Of course I cannot run, I'm asthmatic, don't ask me to do that, but because this is just an example, I can run here. And I've given you a clock. Okay, I want you guys to check how much time it takes me to complete this entire circle. Okay, I want you guys to like check how much time does it take me to complete this entire circle. So how would you do that? Okay, how would you do that? It's extremely simple. As soon as I start running, okay, you will take down the note of the time. You will say that, okay, right now it is 19:47 and then like some seconds. Okay, so 19 hours 47 minutes and some seconds. Okay, as soon as I'm like running around the entire round and I'm coming back to the starting point, you will again take down the note of the time. Okay, so maybe it took me like 20 minutes to run around, so that will be 20:07 and then some seconds right over here. Okay, some seconds right over here. Likita, the notes link is down the in the live chat itself. It is already pinned. You can get it from there. Okay, so as you're able to see, then I will just take the difference between both the times, and that is the time that I took to run around the entire circle. Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. It's extremely simple, guys. There's nothing like too difficult about it. Am I right? So talking so fast because this is basic like understanding logic, like nothing too complicated, no programming, nothing like that, no relation to programming as well. Just a fat person running around in a circle, and you need to note down the time. How much time it took me to like complete the entire circle itself. Okay, if you're not able to understand this, you need some help, buddy. Okay, so if you are able to understand this, let's take this example, replace that fat person, that is me, by our code. Okay, so our code is whatever the code is, like say the Python code. Okay, so this is the Python code. So as soon as this particular Python code starts, okay, before that I will just look at the time. Okay, this is the time that is having right over there. Okay, so the time is 19 hours 47 minutes and some seconds. Then I will run this particular line of code. Okay, I will run this particular line of code. As soon as the code completes, okay, running the entire stuff, then again I will look at the time. Then again I will look at the time. Again I will note down the time. Okay, this is the time. Then what I will be doing, I will be just taking the subtraction. Okay, I will be taking the negation. Okay, I will negate them from each other and I will be able to get how much time it took me to run that Python line of code. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. I don't think so that's too hard to understand. Okay, you have a line of code that is going to run. Before running that particular line of code, I will look at the time. I'll make him run. Then as soon as the code stops running, I will look at the time again. I will subtract both the times to get me how much time did it take that particular line of code to run properly. As simple as that. The same example of the fat man running around in a circle, and you are looking at your watch to calculate how much time it took him to run. Okay. Okay, great. If you have understood this, let's go back to the code, because this is something that I'm not going to explain. Okay, because we are not concerned with the code right over here. This is just a code to make sure that you are able to understand that, okay, why NumPy is better than Python. So I will not be explaining what I have done right over here. Like I will explain it like in a short sense itself. I will not be going into the code because this is just an example. This is not meant for you guys. This is just to make sure that you are able to see how much fast NumPy is when compared to normal Python. Okay, so right over here I have imported another package of Python, that is the time package. Now the time package is basically a package that contains, just like NumPy. NumPy is also a package. Time is also a package. NumPy is for numerical Python. Scientific computation and all those kind of stuff is in NumPy. Everything that you need to do related to time is present in the time package itself. To import this package, it's extremely simple. Just write import and then time. It will import it for you. Right over here, we are also importing NumPy. Okay, so import numpy as np. So because numpy is a very wordy, like it has a lot of words. Okay, so numpy, 5 words that you have to write every single time. So we are nicknaming it as np. Okay, this is usually can nickname is at anything, can nickname it as Shaurya, as Carrie, as Goku, as Midoriya. You can nickname it as anything, but the normal standard way of nicknaming numpy is np. Okay, is np right over there. Are you guys able to understand that? Please do let me know, guys. Yes, these are the only two libraries that we require for just understanding this. Okay, are you guys able to understand this? Please do let me know, guys. Great. So the next particular thing is right over here, this particular code. Okay, I'm not explaining this code, but I'll just let you know that this code is basically generating a list of 1 billion elements. Okay, you can calculate the number of zeros. If I'm wrong, just like let me know. But I'm assuming it is 1 billion when I was writing the code almost like 1.5 years back. So 1 billion elements will be there in this particular list that will have values ranging from 0 to 1. Okay, random numbers in this list of 1 billion elements. Each of these numbers will be from 0 to 1. Are you guys able to understand this? Please let me know, guys. Great. Again, I will just explain to you guys once again. Never ask me to repeat, okay? Because I don't know what you want me to repeat. The joke, which was extremely shitty, the topic, or something else. Whenever you are not understanding something, write the exact thing that you are not able to understand. Because if you're writing like repeat again, I will just ignore it, okay? Because I don't have that time to let's repeat every single thing that I'm saying. Exactly tell me what you're not able to understand. So at one particular go itself, I will be able to understand, okay, this is not what you're not able to understand. I'll work according to that, okay? It's million, not a billion. Okay, so it's like 1,000, 10,000, lakh, 10 lakh. So it's of course a billion, not a million. You could get that right over here. Okay, why are we importing time? Because like I said, I'm not going to explain this particular concept to you guys. We just are concerned with the results. Okay, this code is just to understand the results. Code, I'm just letting you guys know. If you are able to understand, that's great. If you're not able to understand, you can just ignore it. It's not for you. You just need to concern yourself with the results. That why NumPy is faster than Python. That's it. Okay. So the next particular thing, as soon as I'm running this particular line of code, guys, please look like this. Okay. The RAM, are you guys able to see? Okay, the RAM that you are able to see right over here. Let me just show it to you guys. The RAM, if you are able to see, is 0.81 GB out of 12.68 GB. So 12.68 GBs has been provided to you in RAM, okay, by Google, in which you have utilized just 0.81 GB. Okay, you have 0.81 GB itself. So X is a list of 1 billion elements. Okay, X is a list, Python list of 1 billion elements that has each of these elements from a range of 0 to 1. Okay, as simple as that. Like I said, this code you don't have to understand. This is the code to generate a list of 1 billion elements ranging from 0 to 1. That's it. Okay, so if I am running this particular line of code, you will be able to see that my RAM gets filled up pretty fast. Okay, my RAM is getting filled up pretty fast. If you guys are able to see this. Okay, I've utilized 1.53 GBs of RAM up till now. It is still running. My code is still running. Okay, if you are able to see, my code was still running. Now my code has run properly. I've utilized 8.28 GB out of 12.68 GB. So the list of 1 billion elements that I made right now utilize almost 7.5 GBs. Okay, the list that I made right now, list of 1 billion elements. Okay, the list of 1 billion elements that I made right now utilizes almost 7.5 GBs of RAM. Okay, that is the size of the list itself. You guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. Hidesh, the code is working absolutely fine. I have not imported random at any point, so you don't have to import it. Okay, are you guys able to understand this? Okay, the list that we made is so huge that it is using 7.5 GBs of RAM right over here. Okay, now what we are going to do is So time.time is basically like looking at your watch. Okay, time is the name of the package that we are using, and time is another function. Okay, it gives you the exact time at that point. Okay, in like seconds, milliseconds, microseconds, and all those kind of shit. Okay, so right over here, time.time is exactly like looking at your watch. Okay, time.time is exactly like looking at your watch. Okay, just like in the circle. Okay, we looked at our watch. So looking at the watch is basically time.time. Okay, so I'm saving this time. Okay, when I run this particular line of code, it will be first, Python will come to this line. It will look at the time. Okay, time.time is maybe 1957 something seconds and something milliseconds and blah 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 blah, and that I'm going to save it into the start variable. Okay, that is the time when this particular code started running. Okay, this is the time when this particular code started running. Then what I'm going to do is I'm going to calculate the mean using Python. Okay, I'm going to calculate the mean using Python. So sum of x, okay, x is a list. Okay, we have already seen how to calculate the sum of a particular list itself. Okay, so you use sum of list, that will calculate the sum of all the elements that is present in the list. Okay, and we are going to divide it by the length of x. Okay, x is a list, so length of the list itself. So here the length of the list is 1 billion. So it will give us the mean or the average that is there. Now once this particular line is over, this particular line has been computed, then we'll come to the last line. Okay, where again time.time is there. Time.time will again look at the watch at that particular instant. Okay, so this is maybe like 2 minutes have passed, so it will just look at the watch. Okay, so it's 19 hours 59 minutes and something seconds right over here. It will minus the start timing from this to give us the exact amount of time it took to run this particular line of code. As simple as that. As simple as that. Are you guys able to understand this? Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Extremely simple, nothing too complicated, just the logic. Okay, just the logic. You just need to understand the logic. You don't have to look at the code. You don't even have to look at the code. You just need to understand the logic. Okay, if you're trying to understand the code, do not do that. This is not for you. You just need to understand the logic itself. You understood the logic that, okay, we look at the time, we run a particular line, we look at the time again, we subtract both the times, we are able to get the time, how much time it took to run that particular line of code. That's it. That's all you need to understand. Nothing more, nothing less. Okay, that's it. Okay, again, if you don't understand that code, Mithun, it's totally fine. You don't even have to understand this code. This is not, we are not coding right now. We are just trying to understand a topic. So those who are trying to understand the code, please thamba. After the class, you try to understand the code, because we need to go to coding right now. This is not the coding that we are doing right over here. Okay. Okay, so as soon as I'm running this particular line of code, it will give me the exact amount of time it took me to run that line. Okay, so as you're able to see, it is taking a lot of time. It will almost take almost 2.5 minutes or something like that. So we have some time. If you guys want to talk about something, it's fine. If not, then we'll just sit in silence. Okay, like I said, Dhyanti, you don't have to look at the code. Okay, we don't have to understand the code. Shubh Jain, sir, I got my DevTown certificate for Instagram clone, but I didn't got the certificate for Google and Microsoft. Okay, Shubh Jain, I think so. The deadline for the Instagram bootcamp was 27th. How can we send the certificates of project submission before the deadline ends? Okay, we cannot do it for every single person, na? Like every time somebody is submitting, we are going to check their code and then send them the certificate. That is not going to happen. So once on 27th midnight, the submission deadline has been hit, we'll close down the form. Will take 3 to 4 days to look at all the projects, check whether the correct submission has been done or not. If it has been done, then we'll send out the certificates. Okay, so that is how we send out the certificates, guys. Okay. That is the reason why Circle we are using Google Colab and we are not working on our local laptop, because most of the people have laptops that are like having 4 GBs of RAM or 8 GBs of RAM at the maximum. So if you try to run this code in your laptop, it will crash. That is the reason why I'm using Google Colab. So right over here, as you are able to see, it took us 87.26 seconds. Okay, 87.26 seconds. That's almost 1.5 minutes. Okay, that's almost 1.5 minutes. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Okay, so now the exact same thing we are going to use NumPy. Okay, if you guys remember, we have given a nickname to NumPy, that is NP. Okay, that is the nickname for NumPy. So that is the package, and we are going to use the mean attribute, the mean method from the NumPy package. Okay, so we want to calculate the mean of X. Okay, that is the code to do that. So NumPy NP, that is the nickname for NumPy, dot mean, that is I want to calculate the mean of this particular list, and the list that I want to calculate the mean of is X. Okay, that will give me the mean of the entire list itself of 1 billion elements. That almost takes 7.5 GBs of your space. As soon as I'm running this, you will be able to see that it took me less than a second to do that. It took me less than a second to do that. Okay, and that is what I'm trying to make you guys understand. It took us 1.5 minutes by using just normal Python, and it took us just less than a second to calculate the mean using NumPy. That is the reason why we prefer using NumPy over normal Python when it comes to scientific computations. Now, when you go into machine learning, deep learning, even though you're not familiar with it right now, it is a ton based on like computations itself, just mathematical computations happening in the background by your computer. Of course, you don't have to do that. That is the reason why we are using machine learning and deep learning. So if you want to make a particular project, and if you're just using normal Python, it would never work. It will take years to complete. Okay, and that's the reason why we use packages like NumPy and Pandas to help us fasten the entire process of computations. Okay, that is the reason why in when you come to machine learning, it's fine. Machine learning or deep learning at a very higher stage, you require like special hardwares as well. Not just a CPU is not enough. Okay, you require a GPU. Sometimes you even require a TPU. Okay, so of course not everybody can afford that as well. That is the reason why we use something like Google Colab. Okay, Google Colab provides you a GPU for free, it provides you a TPU for free, it even provides you a CPU, RAM, and everything. Okay, you don't have to invest any money, and you can do it from your phone as well. So that is the point that I'm trying to make. Okay, you need to make sure that your code is highly optimized and fast. That is the reason why we choose NumPy all the times. Are you guys able to understand why we are choosing NumPy? Please let me know. TPU, basically the full form, just like CPU, then GPU, you are having TPUs as well. TPUs is tensor processing units. Okay, if you are familiar, if you are a tech geek or something like that, the Pixel phone, that is the new Pixel phone that was launched by Google, it has a tensor chip. That is also one of a kind of a TPU for mobile devices. Okay. Of course, TPUs aren't something that you can buy off. Only Google has it, and Google rents it out to us. But yeah, TPUs is also very important. TPU is tensor processing unit, guys. Great. So let's move on from right over here. Now, the core concept of NumPy is its ND arrays. Okay, like I said, there's no arrays in Python. We only have lists. But NumPy as a package contains something that we call as ND arrays. It's not an array. It's not a normal array, and hence we call it as ND arrays or n-dimensional arrays. Okay, the full form of ND is n-dimensional array right over here. Okay, so an ND array is a multi-dimensional array of elements of all the same type. In other words, an ND array, so in lists you could have like a different data types in the same list itself. You can have a string, a boolean, an integer, a float in the exact same list. But compared to that, when you compare it to ND arrays, you can only have an ND array of a particular data type. You cannot mix data types inside of ND arrays. You can have an ND array of list, you can have ND array of integers, you can have an ND array of floats, you can have an ND array of boolean, you can have an ND array of strings, but you cannot mix it. That is the first difference between lists and ND arrays. Okay, ND array is a grid that can take on many shapes and can hold either numbers or strings. In many machine learning problems, you will be often find yourself using ND arrays in many different ways. For instance, you might use an ND arrays to hold the pixel value of an image that is fed into a neural network for image classification. So basically what happens is your images that you see at any point of time, it's nothing else but pixels at the end. Okay, so let us try to understand this. Like we can skip over that as well. Let's just like, if I've told you guys this, I should cover it as well. So when you sit very close to a old TV, or you bring your phone very close to your face, or you look at your desktop at a very close range itself, you will be able to see some like small boxes. Okay, you will be able to see some small boxes like this. Have you guys seen this? Please do let me know, guys. Have you guys seen this? Please do let me know, guys. Have you guys seen this? Please do let me know, guys. When you sit very close to a particular TV or phone or something like that, you must have seen like these small boxes that are there. If you have not seen it, dude, like what are you doing in your childhood? Even I did that, and I was like fucking dumb in my childhood itself. Even now I'm dumb, but still. Okay, if you have not seen it, no issues. You can just Google it, pixels on TV screens, or you can just like, if you are having a TV in front of you, just go and sit near it. Okay, just switch on the TV first of all. So that is how like the all these like different devices basically work. Now the main particular point is, any image, any video that you're watching on that particular screen is basically nothing else but pixels that are there. Okay, so each of these images, like you're having a 4K image, that means you are having a 4000 pixels that are there on one of the sides. You're having a 1920 by 180p like image quality, so that is again like 190 pixels on the top and 1080 pixels on the left hand side. So that is how you basically represent it. Now each of these pixels is nothing else but 3 sets of LEDs. Inside each of these pixels, you will be able to see R, G, and B. Okay, you will be able to see these 3 LEDs that are there inside of every single pixel, and every color that is possible, humanly possible, that can be made, can be represented using these 3 like colors itself. The intensity of the colors, we can vary it. Okay, so red is like 100%, green is a bit less, and blue is a bit less. It will result in some particular color itself. So each of the like images that you see, every single image, it's consistent of this particular pixel, very small pixels that have these 3 R, G, and B like LEDs inside of it. So the same thing, so every image, so a computer does not understand images. Okay, computer does not understand images. They have no idea. They don't have a brain of any sort. They understand numbers. Okay, they understand numbers. So what we have done is, each of these pixels can be represented, okay, can be represented in the format of R, G, and B values. Okay, so red ranges from 0 to 255, green ranges from 0 to 255, B ranges from 0 to 255, while 0 being the least, okay, that there is no red color, red bulb is off, and 255 means that it is at the maximum intensity itself. Okay, so now if I'm having a particular image, okay, this is a image that is totally red in color. Okay, it has 4 particular pixels. Okay, it is a 4 pixel image, and it is totally red in color. So this is red, this is also red, this is also red, this is also red. So this is what you are able to see. Okay, this is what you are able, just give me a second, guys. So this is what you are able to see. Now what a computer is able to get on its own is basically, a computer will be able to get a matrix. Okay, it will be able to get a matrix that will have 3 values inside of it. Okay, so it is 255 comma 0 comma 0, then the second value is 255 comma 0 comma 0. Okay, then the third value is 255 comma 0 comma 0, and then you're having another value 255 comma 0 comma 0 right over here. Okay, so you represent this image in the format of a matrix. Okay, a 2-dimensional matrix right over here that has a value of 25500, 25500, 25500, 25500, and you can even represent this as well in a 3-dimensional structure. Okay, you can represent this as a 3-dimensional matrix itself, as you are able to see right over here. Okay, so this is a 3-dimensional matrix which has a length and a width of 2, that is the image itself, and a depth of 3. Okay, it has a depth of 3 right over here. The first one represents red, so it will be 255. So the first boxes are all 255, and all the other boxes that are there in the background have a value of 0. Okay, that is for blue and the green channel. So you can represent this two-dimensional matrix. Okay, you can represent this two-dimensional matrix that was a representation of this image in the format of a three-dimensional matrix as well. You can represent it in the format of three-dimensional matrix. Why 255? Because that is the standard. Okay, that is how it has been defined. Okay, there's no like, you don't need to find reason in everything, that why are we alive. Okay, we don't answer those questions. We know it is from 0 to 255. It can be 100, it can be 200. We don't care about that. The maximum value that can be there is 255. The minimum value that is there is 0. Of course, there is some logic behind it, but nobody asks it in the interview, so I also have no idea about it. Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. What is array? So array is basically something that does not exist in Python. Simple definition. Okay, okay, great. Now that you have understood this, okay, I don't know why I haven't made you guys understand that. Okay, so there are several ways to create ND arrays in NumPy. Okay, we will be looking at those methods as well, because of course we are here to learn NumPy, so that is important for us. So let's get started with it, guys. Okay, to use NumPy, first of all, we need to import NumPy, and we are going to provide it a nickname, that is NP, so that we don't have to use NumPy again and again. We will just use NP right over here. To create a one-dimensional ND array that contains only integers. So right now what we are trying to do is we are going to convert a Python list to an ND array. Okay, we are going to convert a Python list in an ND array right over here. So what we are going to do right now is we are having np.array. This is the method that np is the NumPy package. We are having the method that is array. Now this method takes in our list, okay, our Python list, and it converts it into an ND array. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Okay, so this particular line of code is basically converting our normal integer list, Python list, into an ND array. So if I'm running this particular line of code right over here, we are able to get an ND array that has 1, 2, 3, 4, 5. It looks the exact same as the list. There's literally no differentiation when you are seeing it. But yeah, this is a list. Sorry, this is an ND array. And as this is just one dimensional, so we call it as a 1D array. Okay, we call it as a 1D array because n represents n, that is the number of dimensions, n dimensional array, ND array. So we call it as a 1D array itself. Okay, so let us move on to the next particular part, shape of an ND array. Another important property of an array is their shape. The shape of an ND array is the size along each of its dimension. For example, this is a one-dimensional ND array. Maybe some of it is a two-dimensional as well. But what is its shape? Okay, it has one particular row and it has 1 and 5 particular columns. Okay, there might be a two-dimensional ND array that has 2 rows and 2 columns. There may be a three-dimensional ND array that has 2 rows, 2 columns, and 3 in depth as well. Okay, so this shape of the ND array, okay, sometimes you need to require to know it as well, that okay, what is the number of length, what is the depth, what is the width. Okay, that is also something that you need to know. Okay, so right over here, what we are going to do is we are going to have an ND array of one-dimensional ND array that we are able to create, and this is the exact same ND array that we created just like 2 seconds ago. Okay, we are converting this particular list to an ND array. Once we have converted that, we want to check the shape, that is the shape of this particular ND array, this 1D array. What is the shape of this array? To check that, it's extremely simple. You just write x, that is our ND array, dot shape. Okay, that will give you the shape of the ND array. Okay, similar to that, if you want to check the type of x, so x is an object, what is the data type of this particular object? Okay, so that will come out to be an ND array itself. Okay, that is the data type of this particular object. It's an ND array. X is an ND array. And what is the data type of the elements that are contained inside of the ND array? Okay, what is the data type of the elements that are contained inside of the ND array? That you can check using this particular attribute, that is x dot d type. Okay, that you can check using this particular attribute, that is x dot d type. Are you guys able to understand this? Please let me know, guys. See, the best part with Python is even if you're not able to understand what I'm speaking, after just reading the code itself, you will be able to understand what you have to do or what this particular line of code does. Even if you're not listening to me properly, if you're not able to hear me or something like that, but you are able to read, okay, I hope that everybody has that basic understanding of English reading itself. So X has dimensions, X dot shape. So okay, X dot shape will give me the dimensions of X. What is X? X is an ND array. We learned about it previously. Type of X, we learned about it, gives the data type of the object that it contains. So X, what is X? X is an ND array. So it will give us the answer of ND array. X dot D type. D type basically means data type. Okay, the elements in the X are of type. That is the data type of the elements itself. That is integers. Okay, so if I'm running this particular line of code, you are able to see that we are having the ND array as 1, 2, 3, 4, 5. Okay, then after that we are having, okay, then after that we are having our X is an object of type class numpy.nd arrays. So that is the class or the type of the X that we are having right over here, and the elements in X are of data type int 64. Okay, so it's a 64-bit integers itself. So that is the data type of the elements that are there. Okay, we can see that the shape attributes remains the same. So the shape attribute, as you're able to see, is 5 comma nothing. Okay, so what do you mean by 5 comma nothing? Why not 5 comma 1? Okay, we know that there's one row, right? There's one row right over here. So if I'm writing 5 comma 0, why 5 comma nothing? Okay, why not 5 comma 1? Okay, the reason of that is pretty simple. There cannot exist anything that is 5 comma 0. Like, you're having 5 columns but no rows. Is that possible? No. So by default, when you're just writing 5 comma nothing, that means 5 columns and 1 row. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Why we are having 5 as the shape? Why we are having 5 comma nothing? Okay, why not 5 comma 1? Because 5 comma 0 cannot exist. Okay, you cannot have 5 columns and just 0 rows. So the minimum to minimum that is there is, we are writing 5 columns and you need to have 1 row. Okay, so that is what I'm trying to explain to you guys right over here. Great. So the next particular thing is, let's move on from right over here. So right over here, I've just made a particular, as you are able to see, this is a list of strings itself, and we are going to convert it into a NP array. Okay, so as you are able to see, this will be converted into an NP array. And if I'm running this line of code, it works the exact same way. There's no difference. The only thing that you will be able to see is U5. The data type right over here is U5. Okay, I want you guys to find it out. So the full form is Unicode 5, but I want you guys to research a bit about it as a assignment. I've already provided you guys with a link right over here where you can go and start looking at, so what is Numpy, what is int64, what is U5 or Unicode 5 or something like that. Okay, so all these different things that are there, that is like int32, int64, int128, int256, then you're having Unicode 4, 5, 6, 7. Search about it. Okay, try to understand what they are. I've already given you a link right over here where you can start with the exploration itself. This is something that I want you guys to understand, because up till now we have learned about strings, we have learned about integers, we have learned about floats, boolean, but what is int64? What is Unicode 4, okay, or Unicode 5? Okay, I want you guys to find it and learn about it. That is your assignment for today. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Great. Let's move on from right over here, guys. The next particular thing that we are going to look at is okay. Yeah, so if you are, so lists can contain multiple data types as well. I've already told you guys. Okay, lists can also contain multiple data types at any point of time. So you are having this particular integer, you are having this integer, this is a string, and this is a normal list. But what happens if I am feeding this list to an ND array? Okay, I want to convert it into an ND array. Now the problem with this is that we have already learned that an ND array cannot contain like elements of different data types. Okay, all the elements in the same array should be the exact same. It shouldn't be different. Okay, so due to that particular reason itself, if you are trying to run this particular line of code, what it will do is it will convert all the elements that are of the integer type, okay, integer data type into strings. Okay, it will typecast it from integer to strings directly. So all the elements in the nd array will be strings right now. If you're looking at this from right over here, you are easily able to see that all the integers got converted into strings as well. All the integers got converted into strings right over here. Now, why not all the elements got converted into integers? That is also a fair question. But okay, like we are running this code, I'm able to understand we cannot contain multiple data types in the nd array itself, so we converted into strings. But why not integers? How would you convert word as a word into an integer? There's no possible way of doing that. That is the reason why we convert all the integers to string, because that is simple and easier as well. Are you guys able to understand this? Please let me know. Yes, Rohit, there will be a project for some like certification as well. Okay, are you guys able to understand this? Please let me know, guys. Sir, learning always has a value, but sir, does the certificate has value? How will it help us? Please tell. So the certificates basically will be issued to you by DevTown, Microsoft and Google. It will be a certificate I've already shown to you guys. The certificate has value, but only if you guys are able to understand that not everybody. Okay, see, we have made sure that when only those students who are attending the class, having the attendance, only those students are able to get the DevTown certificates. Only those students who have 100% attendance, they attended the class live, as well as whatever project that we made, they did that project themselves, they didn't copy it from somewhere else, they submitted the project. Only those students are able to get the DevTown and Microsoft certificate, sorry, Google and Microsoft certificate. So due to that reason, these certificates, we are able to make sure that only students who are able to pass are able to get the certificate. That is, they have the knowledge associated with it. When you put these certificates on your resume, the interviewers will ask you 1 or 2 questions related to that to check your knowledge, whether you really have completed the entire thing, or you are just like, these are some fake certificates that you have got from somewhere else, or you have cheated in the examination. So they will ask you 1 or 2 questions. If you're able to answer that, then yes, these certificates have value. Like they will be able to understand, okay, these are the topics, you know, full stack web development, you know, data science a bit, and they will continue with the interview further on. Certificates add value to your resume from the perspective of experience, okay, and the perspective of knowledge for the interviewer purpose. Okay, are you guys able to understand? Agam Garg, are you able to understand Agam Garg? Yes, you will be getting the certificate on your email itself, of course. Ooh, so let's continue from right over here. Did I complete it? Yeah. Okay. So let us look how we can convert, how we can create a 2-dimensional ND array as well. Okay. So it's actually pretty simple. Let us look at a particular example right over here. Okay. We are having a particular 3-dimensional ND array that I want to like make 1 2 3 4 5 6 7 8 9. Can I represent this this 2-dimensional ND array as 3 1-dimensional ND arrays? Can I represent this as 3 1D arrays, guys? Okay, like I'm having a list of 3 1D arrays right over here. That is 1 2 3, then comma, that is the first element, 4 5 6, then comma, that is the second element, and then 7 8 9. Can I do that? Please do let me know. Can I represent this 2-dimensional ND arrays as a list of 3 1D arrays, guys? Are you guys able to understand this? Please let me know. Great. And can I represent this as a list of 3 1D lists, 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9? Can I do that? Can I do that? Can I represent this each of these 1D arrays as 1-dimensional lists itself? Can I do that? Please let me know. Great. So what is this? This is a list of lists. Okay, this is a list of lists right over here. As simple as that. Are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know. We are having a 2D array. Okay, we converted it into a list of 1D arrays, and then we converted it into a list of lists. And that is how you represent a two-dimensional ND array inside of Python. This is how you represent a two-dimensional ND array inside of Python. This is the exact code. This is what I'm trying to make you guys understand. Okay, so if I'm going back to my code itself, you will be able to see that the exact same thing that I showed to you guys has been written right away here. 1, 2, 3, then 4, 5, 6, then 7, 8, 9, and then there's one more row that is 10, 11, and 12. Okay, so if I'm running this particular line of code, it will create a two-dimensional ND array for me. And as you are able to see, this is the ND array. This is the ND array that we have created. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, are you guys able to understand this? Please do let me know, guys. Also, the dimensions, the shape of this particular two-dimensional ND array. Okay, the shape of this particular two-dimensional ND array right over here is 4, 3. That is rows, column. Okay, that is rows, column. Okay, always remember RC. Okay, always remember RC. Remote control cars. Okay, RC. There's no CR. Okay, there's always RC. Remote control cars. So row first and then column. So number of rows, then number of columns itself. Okay. Akhilesh Pandey, how many times you are asking? I've ignored you up till now because you are there in the entire boot camp up till now. You can be there after the class is over as well. Okay. There's nothing that can be done. You have to sit through the entire class. Okay, great. So let's continue from right over there, guys. The next is we can almost check the number of elements. So y dot size is also a method that we are having that gives us the number of elements that are there in a particular list. Okay, so right over here it's 4 rows and 3 columns. That is 4 into 3. That is 12 number of elements. So it will give us y dot size will give us 12 elements. Okay. So earlier 5 comma nothing basically. So there, because we don't write like nothing comma 5 is like you don't write it like that. Nothing comma 5. It's not like that. So by default, whenever you are having something like you're having just like a 1D array, you just write 5 comma nothing. That's it, because you are not concerned with the rows itself. Okay. Whereas in the case of the every single 2D, 3D, 4D, 5D, 12D or something like that, you always go with RC. Okay, you always go with RC. Okay, great. So like I said, guys, y dot size will give you the number of elements. Okay, y dot size will give you the number of elements right over there. And right over here, we are having 12 elements. Okay, again, we are having numpy nd arrays, that is the class, and we are having a data type of 64 int 64. Okay, are you guys able to understand this? Please do let me know, guys. Are you guys able to understand this? Please do let me know, guys. Great. So now I'll be showing you the attendance link for today, guys. Give me a second. Also, guys, if you want to connect with me, you can connect with me on both LinkedIn as well as on Instagram. I've provided the links to both my profiles down in the description of the video itself. So if you are interested to connect with me, if you want to talk to me about something or just like you want to do time pass at any point of time, if you have any questions, queries or something like that, you can always approach me on LinkedIn or on Instagram. Both the profiles I've already provided the link down in the description itself. So at any point of time, you guys can reach out to me. Okay, I'm always there for you guys. Okay. Let me take the link. Today it's day 4, if I remember it correctly. Day 4 right over here as well. Responses are open. Send link, copy, shorten, copy, or QR code. This is not the website that I wanted. QR code. V. Download 4. Okay, so you guys can go ahead and scan this QR code for today's attendance, and then we'll be ending the class today. Okay, we'll be continuing from tomorrow onwards, guys. Let's be tomorrow again at the same time, 7:30, and we'll continue from right over there. So thank you so much, guys, and have a great night ahead or a great dinner or anything that you want. Okay, so thank you so much, guys. Thank you, guys. Thank you. Oh shit, it just went down.